got astronomy and physics, botany and ecology, zoology, geology, chemistry and biology. Wanna understand the world and all that it is? Then sit back and kick it with this list of science whiz.
Hello everyone, welcome to today's show. I'm your host, Miss Liz, the Science Whiz. Today we're going to be learning about Earth's movement in space and how that affects our everyday life. We will also learn why some areas of the Earth experience much more variation in their weather throughout the year. So let's make moves. The Earth is always in motion, rotating around its axis. What's an axis, you ask? Imagine you took a stick and stuck it through the North Pole and it came out the South Pole. This is the axis. The Earth is always spinning around it, kind of like a top. Rotation is the spinning motion of a planet on its axis. The rotation of the Earth is why we have day and night. Try this simple model to see how. Shine a flashlight at any ball. Rotate it in a circle. Where the ball is facing the flashlight, it's daytime. Where it's pointed away from the flashlight, it's night. Make it daytime. Let's make it daytime. Keep spinning it. Daytime. Oops. Daytime. Daytime. Nighttime. Good job, guys. Good job. We did science. Good job.
Good job.
Yay! The Earth is also propelled by the sun's gravity. Our planet, like all planets, is always revolving around the sun, following a specific orbit. Revolution is the movement of an object around another object. The Earth's revolution never stops. An orbit is the path an object follows in its revolution around another object. The Earth follows a slightly elliptical-shaped orbit. It is because of this revolution that we are able to measure a year. One trip around the sun is equivalent to a year on Earth. If you look closely at the Earth, you will notice the axis is not straight up and down, but rather is tilted 23.5 degrees. This exact tilt of the Earth is known as obliquity. It is the combination of tilt and orbit that cause many parts of the Earth to experience seasons. Seasons are times of year with varying temperature and precipitation. There are 4 seasons we distinguish on Earth: winter, spring, summer, fall. As Earth revolves around the sun, there are 2 points in its orbit where one hemisphere receives much more direct sunlight than the other. During the months of December and June, we have what is called the solstice. A solstice literally translates to the sun stands still. This is when the sun reaches its greatest distance from the equator, where the sun appears the highest in the sky. In the December solstice, the northern hemisphere is pointed away from the sun, meaning it gets much less direct sunlight than the southern hemisphere. We call this time of year winter in the northern hemisphere. The further you are from the equator, the colder the temperature will be. Many areas even experience snow and below freezing temperatures during this time. The southern hemisphere experiences summer during this time. They've never even heard of a white Christmas. During winter, the amount of time spent warming up in the sun is less than the amount of time cooling down in the dark. Days are shorter and temperatures are lower. During the June solstice, the northern and southern hemispheres swap places. Now the northern hemisphere experiences more direct sunlight, meaning it spends more time warming up and as a result has higher temperatures. We call this time of year summer. In summer, we experience more hours of sunlight than in winter. This is why the days are longer and the temperatures are higher. In between the 2 solstices, the Earth reaches an equinox. An equinox is when neither hemisphere is pointed away from the sun. During this time, day and night are equal, hence the name equa meaning equal and nox meaning night. These equinoxes mark the beginning of spring and fall. The temperature is very similar in these 2 seasons. The big difference is, if you are in the northern hemisphere during the March equinox, temperatures start to rise, marking the start of spring. In September, the temperature begins to drop, marking the start of fall. The exact opposite is true in the southern hemisphere. To see how the amount of time in the sun affects the overall average temperature, try this at-home experiment. In the city of Boston, Massachusetts, the average length of a summer day is 15 hours, whereas the nighttime is only about 9 hours. It is the opposite in the winter. For this experiment, you'll need a heat lamp or a lamp with an incandescent light bulb, a cup of soil, a thermometer, a sheet of aluminum foil, a pen and paper, and a timer. Now, if you're using a lamp like mine, you want to make sure to cover the top up so that no heat can escape. I'm going to use this hat. You'll take your aluminum foil and cover any part of the cup that does not have sand or dirt in it, or that will be out of the path of the light from your lamp. First, I want you to measure the soil before you start. Record that number on your piece of paper. Then, since Boston gets 15 hours of daylight, you're going to turn on your lamp and you're going to set a 15-minute timer. Now we wait. When your timer goes off, make sure to get your measurement of your soil. Try to measure it in the exact same place as before. And record your temperature on the sheet. Make sure you mark it as your daytime measurement. Okay, next, turn off your light. And now we're going to set a 9-minute timer. And now we wait again. When your timer goes off again, get your next measurement. Make sure you record this one as your nighttime recording. Repeat this process 3 to 4 times and see what your overall average temperature ends up to be.
Yo, what you know about the Earth's tilt and axis of rotation, y'all? Talking about obliquity.
The seasons come and the seasons change, and the tilt of Earth's axis is what's to blame. While New York's getting snowed on, Australia's having summer fun. The Earth's cooling down and heating up in the sun. If you're looking for some reasons and you're asking yourself why the Earth has different seasons, look for the answers in the sky.
Winter, spring, summer, fall. Depending on the time of year, the Earth has got it all. It's warming up and it's cooling down. Varying climates roll through because we're going round and round.
Tilted 23.5 degrees is all the angles that it took for seasons to vary all over the Earth, no matter where it is you look.
It's not something that you can feel.
It's not something that you can see.
But the tilt we have on planet Earth is called obliquity.
The seasons come and the seasons change, and the tilt of Earth's axis is what's to blame. While New York's getting snowed on, Australia's having summer fun. The Earth's cooling down and heating up in the sun. Partway through the orbit of Earth, you'll find the equinox. We call those seasons spring and fall that equal day and nighttime rocks.
Next up, we have the June solstice, when the sun's the highest in the sky. They're getting summertime up in the north for more direct sunlight. That's why.
Now south of the equator, it's quite the opposite, you'll see. The weather is cold and the sky is dark, so don't forget your beanie.
Now the December solstice comes again,
And the hemispheres swap roles.
The south is getting their summer break,
while the north is getting cold. The seasons come and the seasons change, and the tilt of Earth's axis is what's to blame. While New York's getting snowed on, Australia's having summer fun. The Earth's cooling down and heating up in the sun. That's our show. Thanks for watching. And remember, without obliquity here in Florida, it would be summer all year round. So let's be grateful that it's there. And as always, keep investigating.